Today, we're diving into a really critical operating model for onboarding engineers in our new reality of remote work and, of course, powerful AI. So let's start with the big question, the one every engineering leader should be asking. You've invested in all the best remote tools, your new hires have AI co-pilots right at their fingertips, but they're still struggling to get up to speed. Why is that? Well, this right here gets to the absolute heart of the problem. See, back in an office, you could literally see confusion on someone's face. Remotely, that ambiguity is completely invisible. And here's the kicker. AI tools can actually make this worse. They generate code so quickly, it creates this dangerous illusion of progress. We call it false productivity, and it masks a total lack of deep understanding. So the solution isn't just more tools. It's a much more disciplined approach. In this explainer, we're going to walk through the exact operating model designed to solve this problem for good. Here's how we'll break it down. First, we'll really define the modern onboarding challenge. Then, we'll introduce pairing as the solution and detail the remote operating model that makes it tick. After that, we'll cover the absolutely essential AI guardrails. And finally, prove the business case with some clear ROI. All right, let's dive into the core challenge for every engineering leader today. It's this constant tug of war between the incredible speed that AI gives you and the deep contextual understanding your team needs to build software that's actually secure and reliable. And what's so critical to get here is how these risks all stack on top of each other. Remote work already shrinks the feedback bandwidth between your senior and junior folks. Now you layer on AI, which cranks up the speed of output, but also the variance in its quality. That's the source of that false productivity we just talked about. And on top of all that, you've got the fact that AI tools have zero business context and can create a massive security risk, potentially leaking your code or customer data out into the wild. So how do we fix this? The answer is to completely reframe how we think about pair programming. This is not some casual, feel-good activity anymore. In this new world, it becomes a disciplined operating model for managing risk and accelerating real competence. So let's be super precise about what we mean. Pair programming is two developers, one task. You have the driver, they're the one with their hands on the keyboard, totally focused on the tactical, get this done part. Then you have the navigator, who's observing, thinking strategically about the bigger picture, asking why. And critically, these roles switch back and forth all the time. To be crystal clear, pairing is a structured discipline designed to compress feedback loops. It is not a junior just watching a senior code. It does not replace your formal code reviews, and it's definitely not just an unstructured, hey, can you help me, call. It's a formal practice for transferring knowledge in real time. And you know what? We can measure its success. Up to speed is no longer just a feeling. It's a set of hard metrics. How long does it take your new hire to get their first safe pull request merged? Is their rework rate actually going down over the first couple of months? And are they completing tickets on their own by, say, week 6? These are your targets. Okay, so we've got the what and the why. Let's get into the how. Because trying to do this remotely without a set of non-negotiable rules, well, it just doesn't work. You have to have discipline. And these rules are not optional. First, the new hire has to drive early and often. It's the only way they build muscle memory and you find out where the knowledge gaps are. Second, you have to be strict about the driver and navigator roles. Third, you've got to time box your sessions to prevent burnout. Next, use 2 separate channels, one for voice and another one for a shared coding surface. Always rotate partners to give that new hire a broad view of the team. And finally, my favorite, the artifact rule. Every single session has to produce a durable asset, like a checklist or a piece of documentation. This makes sure pairing doesn't become an excuse to just not write things down. All right, with a disciplined pairing model in place, now we can safely bring AI into the mix. But this absolutely requires clear governance to stop all that speed from turning into pure chaos and introducing a whole new set of risks. A simple policy like this is a fantastic place to start. Some things are clearly allowed. Generating test ideas, getting code explained, drafting docs. Some things are restricted, meaning they need a human review, big architectural changes, or anything security sensitive. And then some things are absolutely forbidden, no exceptions. Pasting your company's code, secrets, or customer data into public AI models. Now, for accountability, we introduce a concept we call the AI receipt. It's simple. If AI had a real hand in the code, the developer documents it. The receipt captures the prompt they used, the output they got, and, this is the most important part, how they verified it was correct. This creates a really critical audit trail. And this all leads to the verification discipline. The rule is simple. You own the code, not the AI. You have to be able to explain it without the tool open. You have to validate it with tests, and a human has to be in the loop for every critical decision. This is how you shift your team from blind trust to verifiable proof. Okay, so we have the model, but as a leader, I know what you're asking. What's the cost and what's the return? So let's build that business case right now. Let's just be direct. Pairing is an upfront investment. The studies show it can increase initial programming hours by about 15%. You are spending more developer time in the short term. We have to acknowledge that cost to even have a credible conversation about the gains. But the payback comes, and it comes fast. Within 30 days, you'll see a faster time to a safe PR. By 60 days, you're seeing more independent work. And here's the metric that really matters. By 90 days, you will see a measurable drop in interruptions for your senior engineers, giving your most valuable people their focus back. And long-term, that means lower defect costs and better team retention. This chart pretty much tells the whole story. You've got that short-term cost in developer hours, sure, but that is quickly dwarfed by the medium-term payback from less rework and fewer interruptions. And the long-term game is where the real value is hiding. Better quality, higher velocity, and actually retaining the talent you worked so hard to hire in the first place. And hey, this isn't just theory. The research shows that code written by pairs has on average 15% fewer defects. That's a number that translates directly to lower maintenance costs and fewer late-night pages from production incidents. So, if you take one thing away from this, let it be this. Pairing isn't magic. It works when you treat it like a formal operating model, with clear rules, metrics, and real discipline, not when it's just some optional, feel-good vibe. So I'll leave you with a question to take back to your team. Can you, right now, answer this with data? What is your team's time to first safe merged pull request for a new hire? If you don't know that number, that's where you need to start. And second, do you have an AI policy that prevents all this new speed from becoming just entropy? Look, a structured onboarding model like the one we've discussed is exactly what modern engineering teams need to scale effectively. It's the kind of operating model we often help teams design and measure to drive really predictable results.